Introduction. In class 7, you have already learned how objects move. In your day-to-day life, we can see there are many objects around us. They are basically moving. It requires some energies. In this chapter, we will learn force related to force and pressure. What does the distance moved by an object in unit time indicate? You also know that a moving object like a ball rolling on the ground slows down. It may changes its direction of motion. It is also possible that the ball may slow down and also change in the direction. That means when a cricketer or a hockey player when hit the ball, it may increase the speed and another player maybe decrease the speed with the another hockey sticks, or it may change the direction. Did you ever wonder what makes an object to slow down or go faster or change its direction of motion? Let us recall some of our everyday experience. What do you do to make a football move? That means we can hit the football, we can stop the football like that. So what do we do with the football? What is required for that to moving it? What do you do to make a moving ball to move faster? We can hit or we can just kick it. How does the goalkeeper stop the ball? With the help of the hand, it can jump and stop the ball. That means it can prevent the speed which is coming towards him. How do fielders stop a ball hit by a batsman? With the help of the bat, it can play it and the ball can be stopped or it can change the direction or in the speed. A hockey player changes the direction of the moving ball with a flick of the stick that you can see in the TV also when the hockey matches are going on. In all this situation, the ball is either made to move faster or slower or its direction of the motion is changed. So what do we do with all this kind of situation? We often say that a force has been applied on a ball when it's kicked, pushed, thrown or flicked. What is force? What can it do to bodies on which it is applied? Let us understand all these things in this chapter. So let's continue with the next point, that is force. Force is nothing but a push or pull. When you are entering into the any kind of office or in the big mall, there is a door and written over there push or pull. Everybody knows that when you push something, that means the object is moving outside, and when you pull something, object is coming towards yourself, right? Okay. So action like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe the certain task. These are all the tasks that we are doing in our day-to-day life. If we want to pick something from the floor, we have to apply some force. To opening the doors or to closing the doors, we apply some force. Kicking a ball or hitting a ball, we require some force. Lifting and flicking and pushing and pulling are described all these tasks. So all these tasks we have to do the perform, we have to apply some force, and the force is nothing but push or pull the object. Each of these actions usually result in some kind of change in the motion of an object. So, can these terms be replaced with one or more terms? Let's find out. In science, a push or pull on an object is called a force. As I told you earlier, that force is nothing but a push or pull the any kind of object. Thus, we can say that the motion imparted to do object was due to the action of force. When does a force come into play? That means we require some different kind of the forces that we'll discuss in this chapter detail. Let us find out what is that. Force are due to an interaction. That means one object is interact with the another object. That time the forces are basically applied. Suppose a man is standing behind a stationary car in figure 11.2 with all with the car moves due to his presence. We'll see it. You can see in this diagram a man is standing behind a car. It is not doing anything. He is not doing anything. He is not pushing or he is not pulling something. He is little bit away from the car. If this car is stationary, that means steady, it is not moving. Will it move automatically? The answer is no. Okay. Suppose the man now being to push the car, that is, he applied a force on it. As you can see in the another diagram. That means he is pushing behind from the behind the car. What will happen? When he applied the force, this car is starting moving and it is moving towards the force is applied. That means the car may be to move in the direction of the applied force. It is not going in the backward direction. It is going into the forward direction where the force is applied. Okay. So note that the man has to push the car to make it move. That means to moving a car, the man has to apply the force. And the force, what is that force? Force is that called pushing the car. If the man is pushing, that means it is applying the force on the car. That's why due to the force, the car is moving. Next, in figure 11.13a, 3a, both the girls appear to push each other, while the pair of girls in figure 11.3b are trying to pull each other. Similarly, the cow and the man in the 11.3c appears to pull each other. And the girl is in the two situations shown here are appearing forcing on each other. Let's understand with the diagram. Is it also true for a man and the cow? From this example, we can infer that at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object result is a force between the two objects. As you can see, as we have discussed earlier, that the first girls, both girls are basically applying force on each other, but they are pushing itself, right? They are pushing itself. Similarly, in the 11.3b, they are trying to pull each other. That means when they are pulling each other, they are basically rounding the circle. And in the third diagram, a man is basically pushing a bull towards him. Pulling a bull towards him. But what will happen? They both are applying the force. The bull is applying the force on the man and the man is applying the force on the bull. So they both are basically applying the force. Okay? From this example, we can infer that at least two objects must interact for a force. Here you can see all this diagram. Two girls and one man and bull. So we require minimum two objects to apply a force. Thus, interaction of one object with another object result in a force between the two objects. Now, exploring forces. There are various kind of forces are there. You may have understand and you may have learned in the previous classes. Here we'll see. Have you ever seen a game of tug of war? You might have played in your lower classes on the ground when you go into the PT period or some games period. Tug of war you might have understand and you have played also. Here you can see in this diagram, two teams are opposite. Correct? One side three boys and another side one boy and two girls. Here they are pushing each other. What is happening? Here both of them are applying the force on the rope. If one can force little bit powerful, then what will happen? The team will be weak. That means this another team has the very more force in comparison of the another team. This is called the tug of war game. You have already learned and played also. Clear? In this game, two teams pull at the rope is opposite direction. The member of both teams try to pull the rope in that direction, as I told you earlier, and sometimes the rope simply does not move. That means both teams apply the same forces. That means they are not moving forward direction or the backward direction because both the teams are applying same forces. The team that pulls harder, that is apply a larger force, finally wins. As I told you, if the team A or team B, if team A is applying the force, very powerful force or the greater force than team B, then team A will be win. Correct? If the two forces act in the opposite direction on an object, the net force acting it is the difference between the two forces. That means if they applied two forces but in the opposite direction, there is the net force. Net force, that means the both objects are basically applying the force on each other, so there will be no differences. As I told earlier in the tug of war, if the both team apply the forces on the rope and the rope is not moving, that means the net forces becomes zero. That I have already told earlier. So we learn that a force could be larger or smaller than the others. Correct? That means you can see in the example that is in your class, if the two boys are pushing each other, one is the very strong and one is little bit lower stronger, then what happened? The stronger boy can easily push or pull the other boy. So the force can be powerful or less powerful, we can say. So the strength of a force is usually expressed by its magnitude. So what is the strength? It's basically expressed by its magnitude. What is magnitude? That we'll see later. We have we have also to specify the direction in which force is act. That means in which direction we have to apply the force that we can push and pull the object. And if the direction of the magnitude of the applied forces changes, its effects also changes. That means, for example, I give you one more example here. When a bowler basically throw the ball towards the batsman, and the magnitude is basically towards the batsman only, and the batsman is basically hit the ball with the bat and it changed the direction. That means the direction of the ball has been changed. That is called a magnitude. A force can change state of motion, as I told you the earlier example. Clear? So how it has changed the motion? Let's see. Let us now find out what happens when a force acts on an object. You might recall similar situation when you are just playing football or volleyball or some like cricket, all these things. In all these games, you have changed the direction. Even you can just increase the ball speed or decrease this ball speed. These are all basically different kind of the motion and the magnitude. So, for example, while taking a penalty kick in football, the player applies a force on the ball. As you know that how the footballer and how the soccer player are hitting the ball. Clear? Okay. Before being hit, the ball was at rest and so its speed was zero. And after kicking, what will happen? It applied the force, makes the ball move towards the goal. Suppose the goalkeeper dives or jump up to save the goal. That means if the ball is on rest and the football player hit the ball, what will happen? The ball has some getting energy that is in motion and it can also change the direction. That means change in the momentum. And what do goalkeeper do? It will try to save the goal and jumps and try to stop the ball. Clear? By this action, the goalkeeper tries to apply a force on the moving ball, and the force applied by him can stop or deflect the ball. Deflect the ball. Saving a goal being scored, if the goalkeeper succeeds in stopping the ball, his speed decreases to zero. That means if the goalkeeper stops the ball, again ball will come onto the wrist. Clear? Like that, the goalkeeper can save the goal and the speed of the ball is decreased or maybe zero, and the magnitude will become zero here. This observation suggests that a force applied on an object may change its speed. As you know that uh, how the football player has applied the kick on the ball, it has that apply the object and the change speed. The force is applied the object and the change speed. If the force applied on the object is in the direction of its motion, the speed of the object is increased. Clear? That means if the ball is at rest and the football player hit the ball, what will happen? It is applying the force with his foot on the ball and the ball getting the speed. Clear? That means the ball has got the force onto it and the ball getting the speed, and it is also change the magnitude and it can also change the direction. If the force is applied in the direction opposite to the direction of motion, then it results is a decrease in the speed of the object. That means if a goalkeeper try to stop that. What will happen? The goalkeeper is applying also the force on the ball towards coming to him. What will happen? The ball which is getting the speed, that means in motion or the force which is basically applied by the goalkeeper, can be stopped it. That means again the speed of the ball is decreased or stopped. A change in either the speed of an object or its direction of motion or both is described as a change in a state of motion. So what is state of motion? The speed of the object, or if the direction of the motion, or both. That means object speed and motion both will describe the change in state of motion. Yeah. Thus a force may bring a change in the state of motion of an object. So what do we understand in this video? The force is basically applying of any object. It can change the state of the motion. That means the speed may be increased or decreased, and it can also change the direction of the object.